Have you ever wondered how requirement engineering can be improved with object-oriented techniques? Well, you're not alone. Requirement engineering is a vital phase in the software development process. It's the phase where we gather, analyze, and document the needs, expectations, and constraints of stakeholders. Now, imagine applying object-oriented techniques to this process. It results in structured, understandable, and maintainable requirements that align seamlessly with object-oriented software design principles. This method has the added benefit of effectively translating stakeholder requirements into models that resonate with object-oriented paradigms. Requirement engineering involves several key steps: elicitation, analysis, specification, and validation. Each of these steps is a crucial component of the process, and object-oriented techniques can be integrated into each one. So, buckle up, because in this video, we will explore how object-oriented techniques integrate into each of these steps. The first step in requirement engineering is requirement elicitation. This is where you gather the needs, expectations, and constraints of all the stakeholders. It's like a meet and greet, where everyone brings their ideas to the table. Now let's talk about how object-oriented techniques come into play. They help us understand the system in terms of objects and interactions. Imagine you're at a party, and instead of people, you have objects. They interact, they communicate, they have relationships. The object-oriented approach is like being a social butterfly at this party, understanding who's who and what's what. A popular object-oriented technique used in requirement elicitation is the use of use cases. They describe the interactions between users, or actors as we call them, and the system to achieve specific goals. Think of it as a storyboard, where every frame captures a unique interaction. Use cases help stakeholders articulate their needs in a context-based manner, making sure everyone is on the same page. Moving on, we have interviews and workshops. These are like deep dive sessions, where you gather detailed information from stakeholders. The focus here is on the objects, their attributes, and relationships. It's about getting to know each object intimately, understanding their characteristics and their roles. Lastly, we have domain modeling. This involves identifying key entities or objects in the domain and understanding their relationships. It's like drawing a map of the real world and marking all the important landmarks. Domain modeling helps in mapping these real-world concepts to software objects, building a bridge between reality and the virtual world. So, to sum it up, requirement elicitation is all about gathering requirements and understanding the system. Object-oriented techniques like use cases, interviews, workshops, and domain modeling help us in doing just that. They allow us to view the system as a network of objects, interacting and collaborating to achieve a common goal. These methods facilitate understanding the system in terms of objects and interactions, and with this understanding, we are better equipped to navigate the rest of the requirement engineering process. Once requirements are elicited, they need to be analyzed. This is where object-oriented techniques shine, aiding in the breakdown of complex requirements into manageable components. Let's start with class diagrams. In the realm of object-oriented techniques, class diagrams are the backbone of requirement analysis. They give us a bird's-eye view of the system, representing objects, their attributes, and relationships. Think of them as a blueprint of the system, providing a clear structure for analysis. They enable us to understand how objects interact with one another, how information flows within the system, and how responsibilities are divided among different objects. With class diagrams, we are able to sketch a clear map of the system's architecture, paving the way for a smoother development process. Moving on to sequence diagrams, these are the storytellers of our system. They illustrate the interactions between objects over time, in a sequential manner. Sequence diagrams are especially useful when we need to understand specific use cases and the system behavior in those scenarios. They are like watching a play where objects are the actors, and the sequence of interactions is the plot. By visualizing these interactions, we can identify any missing or redundant steps, ensuring a comprehensive and efficient design. Lastly, we have entity relationship diagrams, or ERDs. While not strictly object-oriented, ERDs are indispensable when it comes to data modeling. They focus on the relationships between entities, providing a solid foundation for database design. ERDs allow us to understand how data is stored, accessed, and manipulated in the system. They help us ensure data integrity and consistency, which are crucial for the system's reliability and performance. So, in a nutshell, object-oriented techniques are like a Swiss Army knife for requirement analysis. Class diagrams lay the groundwork, sequence diagrams narrate the story, and ERDs keep the data in check. These diagrams provide a clear structure for requirement analysis, ensuring that we have a thorough understanding of the system before we dive into design and development. Remember, a well-analyzed requirement is like a well-laid foundation. It's the first step towards building a successful software solution. After analyzing the requirements, we move to the next step, which is requirement specification. Specification is the process of documenting requirements in a way that's clear, concise, and unambiguous. Object-oriented techniques make this task easier and more structured. One of the most potent tools at our disposal is the Unified Modeling Language, or UML. This is a standardized language that provides us with a way to visualize and document the design of a system in terms of objects. UML encompasses different types of diagrams, each with its unique purpose. For instance, use case diagrams illustrate how users interact with the system, class diagrams depict objects and their relationships, and activity diagrams show the flow of control from one activity to another. Another vital part of requirement specification is writing requirement statements. These are written descriptions of what the system should do, often based on use cases and other object-oriented analyses. A good requirement statement is clear, concise, and traceable. It describes a single functionality, avoids technical jargon to be understandable by all stakeholders, and is traceable, meaning it can be linked back to its source in the requirement elicitation and analysis stages. The beauty of object-oriented techniques lies in their ability to facilitate communication between technical and non-technical stakeholders. For example, UML diagrams with their visual nature can be understood by non-technical stakeholders, enabling them to participate in the requirement specification process actively. The use of object-oriented techniques in requirement specification is not just about creating a document. It's about creating a shared understanding of what the system should do. It's about creating a blueprint that can guide the subsequent stages of software development. These techniques help in documenting requirements in a clear, concise, and traceable manner. They provide a solid foundation for the next phase of requirement engineering, which is validation, where we ensure that the documented requirements meet stakeholder needs and expectations. But that's a topic for another time. For now, let's remember that a well-specified requirement is the first step towards a successful software project. The final step in requirement engineering is requirement validation. This is where we ensure that the documented requirements indeed meet the needs and expectations of our stakeholders. With object-oriented techniques, this process becomes a lot more interactive and visual, making it easier for everyone involved to understand and validate the proposed system behavior. The first technique we'll discuss is prototyping. By creating prototypes or mock-ups of the system, stakeholders can see firsthand how the system is expected to function. This visual representation can be based on use case diagrams, class diagrams, or any other object-oriented models that have been developed during the specification phase. Prototypes provide a tangible way for stakeholders to interact with the system, offering them a clear picture of how their requirements have been translated into software objects and their interactions. Next, we have review meetings. These are crucial sessions where stakeholders can validate use cases, class diagrams, and other requirement documentation. Discussions in these meetings can center around the properties of the objects, their relationships, and the sequence of interactions between them. This is another opportunity for stakeholders to provide feedback, ask questions, and request clarifications. These meetings help to ensure that everyone is on the same page and that the requirements have been correctly understood and documented. Finally, we have traceability matrices. These are essential tools that map requirements to design and implementation elements. They help ensure that all requirements are addressed and can be traced back to their source. This is particularly useful in large projects where managing a vast number of requirements can be challenging. Traceability matrices provide a clear overview of how each requirement has been incorporated into the system, giving stakeholders confidence that their needs have been adequately addressed. In conclusion, requirement validation is a vital step in the requirement engineering process. It's the stage where stakeholders get to see how their needs and expectations have been translated into a workable system design. Object-oriented techniques like prototyping, review meetings, and traceability matrices make this process more interactive, visual, and efficient. These techniques ensure that the documented requirements meet stakeholder needs and expectations. So that's how object-oriented techniques can be applied to improve requirement engineering. From the initial elicitation of requirements, where we use techniques like use cases, interviews, workshops, and domain modeling, we focus on understanding the system in terms of objects and their interactions. In the analysis phase, we break down complex requirements into manageable components using class diagrams, sequence diagrams, and entity relationship diagrams. In the specification phase, we document the requirements using a standard like unified modeling language and write clear, traceable requirement statements. Finally, in the validation phase, we use prototyping, review meetings, and traceability matrices to ensure that the requirements meet the stakeholders' needs and expectations. Each of these steps is crucial in creating software that meets the needs of its users. Remember, the goal of requirement engineering is to create structured, understandable, and maintainable requirements that align with software design principles.